students, welcome back again to my journey through haloalkanes and haloarenes. So in our previous videos we have discussed the classification, nomenclature and preparation of haloalkanes and haloarenes. So in this video we will see the reactions of haloalkanes, that is what are the reactions that haloalkanes can undergo. So here we will see that haloalkanes can undergo reactions like nucleophilic substitution, elimination reaction and reaction with metals. So this altogether is a very huge topic. So in this video we'll discuss only nucleophilic substitution reaction. So before going on to nucleophilic substitution reaction, let us understand what is a nucleophile. From the word itself you can understand nucleo means nucleus and phile or philic means liking. Okay, so nucleophile means nucleus loving or nucleus liking species. So what does it contain? If it is to like nucleophile, it may contain excess of electron. So nucleophile is a chemical species that donates an electron pair to form a chemical bond in a chemical reaction. So a nucleophile will contain excess of electron or a negative charge along with them so that they can donate those electrons and form a chemical bond. So there are examples for nucleophiles like OH minus or hydroxide ion, cyanide, Cn, NH3, OR minus alkoxide ion, NO2, like that there are different nucleophiles. So nucleophiles always will contain excess of electron. So and there are certain nucleophiles like they possess two nucleophilic centers like cyanide or nitrite. In cyanide, then nitrite, they possess two nucleophilic centers and such nucleophiles are called as ambident nucleophiles. That is, what do you mean by two nucleophilic centers? That is, it can be linked through two different centers. That is, if you consider cyanide, it can be linked through either through carbon or through nitrogen. That is, if it is linked through carbon, that is if the alkyl group and the carbon is forming a bond, then it is called as alkyl cyanides. And if it is forming a bond with nitrogen, then it is known as isocyanides. So these are the two nucleophilic centers, carbon and nitrogen in cyanide. So it is an ambident nucleophile. In the case of nitrite, it can be linked either through oxygen or through nitrogen. If it is linked through oxygen, it results in alkyl nitrites. While it is linked through nitrogen, it is called as nitroalkane. So such nucleophiles which possess two nucleophilic centers are called as ambident nucleophiles. So you just understand nucleophile means they contain excess of electron and they donate those electrons to form a chemical bond. So such species are called as nucleophiles and they have a negative charge. Now these nucleophiles can undergo substitution reaction, then it is called as nucleophilic substitution reaction. Now what is a nucleophilic substitution reaction? See, here a nucleophile reacts with haloalkane. Haloalkane is called as the substrate and a substitution reaction will take place and the nucleophile will take the position of the halogen atom. Halogen atom will get departed as the halide ion and halogen atom is the leaving group and the incoming group is the nucleophile. So this is a nucleophilic substitution reaction. So we'll make it clear. That is a nucleophile that is rich in electrons or they contain excess of electrons, so that will react with alkyl halide or a haloalkane. And what happens? This halogen atom is having partial negative character and alkyl group or carbon atom get partial positive character, and as a result when this nucleophile attacks the haloalkane, this negatively charged nucleophile attacks the positively charged carbon atom forming a bond RNU. And what happens to the halogen atom? Halogen atom, which is the leaving group, get departed as halide ion. So here a substitution reaction take place. Nucleophile attacks or get attached to alkyl group, forming a compound, and halogen atom get departed as halide ion. So here a nucleophile is involved, and so therefore it is known as nucleophilic substitution reaction. Now we'll see the various examples of nucleophilic substitution reaction. Already we saw OH minus, OR minus, CN minus, NH3 are various nucleophiles. When they react with alkyl halide RX, what happens? Halogen atom is departed, and to that position OH group is getting attached. Okay, now if it is alkoxide ion, when it react with alkyl halide, OR group get attached to the alkyl group in position of halogen atom, and halogen atom get departed as halide ion. And if it is Cn minus, again Cn get attached to carbon atom and halogen atom get departed. And if it is ammonia, ammonia take the position of halogen atom, and halogen atom get departed as halide ion. So these are various nucleophilic substitution reactions, and in these various nucleophiles are involved. Now this nucleophilic substitution reaction can take place in two different mechanisms. That is, mechanism, do you know what is mechanism? Mechanism explains the pathway of a reaction. Mechanism means the pathway of a chemical reaction. So nucleophilic substitution reaction can take place by two different mechanisms. One is substitution nucleophilic bimolecular SN2, and another one is substitution nucleophilic unimolecular, also called SN1. So there are two different mechanisms for nucleophilic substitution reaction. They are SN2 and SN1. And in this video, we'll explain the first one, that is substitution nucleophilic bimolecular or SN2 mechanism. So now what is, we know what is substitution reaction. We have learned what is a nucleophile, so we know substitution and nucleophilic. And what is this? Bimolecular. Bimolecular means this reaction follows second order kinetics. That means the reaction rate depends upon the concentration of both the reactants. That is, there are two reactants involved in this reaction. One is OH minus, nucleophile, and another one is a substrate, that is alkyl halide. So here the reaction rate will depend upon both the reactants. That is why it is called as bimolecular, SN2. Bimolecular means the reaction rate depends upon the concentration of both the reactants, the nucleophile as well as the alkyl halide. So now what happens in the reaction? In the reaction, as the nucleophile attacks the alkyl halide, the nucleophile, here is the OH. OH will partially form a bond with carbon. It is shown by dotted lines. So it's only partially formed. So OH will partially form a bond with carbon atom, and at the same time the carbon halogen bond is partially broken, not completely broken. It is only partially broken. So it is also shown by dotted lines. So this is the transition state. So the reaction SN2 mechanism proceeds by transition state. That is, in the transition state, this carbon atom or the alkyl carbon atom is partially forming a bond with nucleophile, as well as the carbon halogen bond is partially broken. So this is the transition state, and this transition state is highly unstable because the carbon atom is attached to 5 atoms or groups at a time. Whereas carbon is only tetravalent, it can hold only 4 atoms or groups at a time. But here in the transition state, it is attached to 5 atoms or groups. See here, OH is one group. There are 3 hydrogen atoms already, and the CCl bond. So there are 5 atoms or groups at a time. So this is highly unstable. This cannot be isolated. So what happens? It cannot withstand, so it will soon form undergo the reaction and the halogen atom get departed as halide ion, and the OH will completely form a bond with carbon atom. So it will form CH3OH alcohol. So this is the reaction that is taking place by SN2 mechanism. That is, it proceeds through transition state, and here it follows second order kinetics. That is, the reaction rate depends upon the concentration of both the reactants. So that is the nucleophile as well as the alkyl halide, and it is a single step process. That is, the nucleophile reacting with alkyl halide and proceeding through the transition state soon changing into the product. So this is a single step process, and it is the transition state cannot be isolated. Now what about the structure? Where is the OH group get attached? You can see in the transition state, OH group is attacking the carbon atom only from the back side, because the carbon halogen bond is not completely broken. So it cannot attack to that position. So the OH group get attached to carbon atom from the back side in the transition state. So in the product, we get an inverted product. That is, we get an inverted product, or we see inversion of configuration. This is because in the transition state already there is a carbon halogen bond. It is not completely broken, so the incoming group cannot attack from that side. It can attack only from the back side. So the product will be inverted, and we observe an inversion of configuration. Now we'll see the features of SN2 mechanism. That is, here no intermediate is formed. The reaction proceeds through transition state, and in the transition state, carbon atom is simultaneously bonded to incoming group, leaving group, and the structure is unstable and cannot be isolated. And this inversion of configuration is similar to the inversion of an umbrella. That is, umbrella getting inverted when there is a strong wind. So that is a good example. The inversion of configuration can be considered similar to the umbrella getting inverted while there is a strong wind. So that is SN2 mechanism. And now, what type of alkyl halides undergo SN2 mechanism? That also depend upon the transition state. What type of alkyl halides undergo SN2 mechanism? That also depend upon the transition state, because in the transition state the carbon atom is attached to 5 other atoms or groups at a time. So already there is a steric hindrance over there. So if there is more bulky groups present, the reaction is not possible, or the reaction take time to go to the product. So depending upon the transition state, only small groups can undergo reaction by SN2 mechanism. Bulky groups cannot undergo reaction, or it will be very slow. The reaction will be very slow for bulky substituents. So when you consider the alkyl halides, the methyl halides will undergo reaction readily by SN2 mechanism, because the alkyl halide, there is only methyl group, means CH3, there is only hydrogen atom, so it will no steric hindrance, so it will readily undergo the reaction. If you consider primary, secondary, tertiary halides, they have less steric hindrance, so they will undergo the reaction very fast. Then secondary and tertiary halides, very less chance of undergoing the reaction by SN2 mechanism. So the order of reactivity of alkyl halide by this mechanism or by SN2 mechanism is primary halide greater than secondary halide greater than tertiary halide. So this is the nucleophilic substitution reaction. Hope you have understood. In the next videos we will see the SN1 mechanism. What is the difference between SN1 and SN2 mechanism? Thank you.